All right, hello everyone. My name's Tony. I'm going to tell you about a programming technique today that I use. And the reason I want to tell you about it is because I get asked about it a lot by my peers and colleagues. They say, why are you writing these crazy type signatures and so on? So my plan is to give them a really good answer to this question. However, I also have another question, and that question, knowing that Ed would be here, is what am I doing wrong? So I'll tell you first of all about the expression problem. So Wadler said that it's a new name for an old problem, and whether or not a language can solve it is an indicator for its capacity for expressing I guess working towards solving this problem. So for those of you who don't know what the expression problem is, I'll tell you what it is. So we have this data type here, the traffic light. It's either red, green, or it's amber. And we cycle through the traffic lights. And the question is, what happens when we need to add a new construct to this data type? So only buses proceed. I think we have a few of these now in Brisbane. They didn't when I was very small, but we do have them now. So the question is, what happens to the functions such as this cycle function and all functions that reference that code? So that code must either change or it fails. So it'll become a non-exhaustive pattern. All right. So the expression problem is, so one way to get around this is to create a new data type, and that is to say reference the old data type, the traffic light, as well as the new case. However, the cycle function will need to be updated. And this, I think this is a question that has tormented me for years, which is, does there exist an appropriate abstraction around this? So how do I get around this constant trade-off? So I believe that there isn't one. I believe that you have to keep trading off. This is a question that has been asked of me, and I think the answer is no. For those of you who have asked it, the answer I think is no. As simple as that. I think there are only trade-offs. We can only sort of trade off against adding constructors to our data types versus having to update our functions that reference those to achieve exhaustive pattern matching. Some of those trades try to achieve economy in both directions, and does that one achieve maximal economy? I still think the answer is no. There are those of you in the room who know why I'm answering that question. Moving on. So what I'm going to do is I'm going to use the lens library to demonstrate one such technique. And again, it's something that I use it regularly, and I don't know what I'm doing wrong. So I'll give you another example of the expression problem. So the either data type, I assume we're at a functional programming conference. We all know what that means. So we have either an A or a B. We have this data type here that is given an A, and either an A or a B return an A. So if we have one in left, we return it. If we don't, return the other one that was given. Now we add a new data constructor to this data type called none, and now the left or function needs to be updated. So the expression problem is, how do I add constructors to these data types without having to update all our referencing functions such as left or? So we'd like to write left or once and write it for all. So we can keep adding these data constructors to our data types without having to update the left or function. So I've renamed, so these are, I guess, are the two versions of either. There's the regular one and there's another one which I've called proly. And we kind of want this abstraction here called has some notion of leftish that takes A and then the leftish thing of A and B to an A. And then once we've written this function, we can keep writing these data types such as either and proly and so on without having to update our functions such as left or. So basically we want to abstract two things, the view of A and the possible existence of that A in TAB. All right, so if we have a look back here at these two data types, the possible existence of A in either is the left, and the possible existence of A in proly is this. Okay, so we want to abstract out that idea. So this is when we start looking at lenses. So who is not familiar with lenses at all? I knew Ed was going to do that. So basically, I'll do my best here actually. So looking at the type signature here, we can think of this, so identity as you might know is simply a container that contains one element, so we can cancel it out. So we have a function from A to A, and then to T of AB to T of AB. So that is to say, modify the A in the TAB to produce a new TAB. So we can think of this as a modify function. Okay, so modify A using this function in that leftish thing. So the reason I've highlighted that in green there is because they're the 2 points that I want to abstract away. Okay, so it's not going to be a function from A to A, but a something of A, and the functor here is not going to be identity, and I'll show you why. But here's how the type would look if we were to abstract those away, right? So P and F have now become type variables. P is where the arrow used to be, and F is where the identity used to be. So basically what I'm going to do is I'm going to show you this technique where I can substitute P with different values and F with different values and get different properties of what it means to view these data types. So when we're talking about potentially existing, like like either potentially has an A and probably potentially has an A, the answer to the question, what do we want to substitute P and F with, is these constraints here, and that is P satisfies choice. So choice is a more constrained profunctor. Does anyone not know what a profunctor is? Sorry, I could tell you, I'd have to write some code. Anyway, I'll come back to that. So basically, yeah, so a prism is where we constrain P, the arrow P by choice. So all you need to know is that it's just more general than arrow and identity. Arrow is an instance of choice, and identity is an instance of applicative, as we saw this morning in our keynote. So here is the code for the type class, and that says that we're abstracted on P and F and the type constructor T, so where T is the either or probably thing. And we've said that anything that has the notion of leftishness satisfies this type signature here. And we have examples or instances of that. So either satisfies it where P is constrained by choice and F is constrained by applicative. Therefore, we can say that they are a prism. So, and we could put other constraints there to get different properties about it. So here I think is, I guess, the important point, which is if we have a look now at our left or function. So prior to this type, it used to be, the signature used to mention the either data type or the probably data type or any others that we may have written, but it now says it's any T such that whatever that says, which is to say it has a some notion of leftishness. And the point is any instance now no longer needs to, you just define the instance and you automatically pick up this function. So you don't need to keep writing this function over and over again for either, for probably, and for any others that you might have some notion of potentially having an A. Okay? Making sense? Everyone should say yes. That's so. There are other data structures that support this notion of potentially having a left, and that is, for example, const, which we saw this morning. However, the constraint on the P and the F are not choice and applicative. It's simply an isomorphism, so it's just whatever it is, profunctor and functor. So they're weaker constraints. And then again, here's another data type where it has some notion of potentially having an A. It has a prism. Another one has a prism, this data type here, which some of us use. And then of course, just a pair of an A and B. This doesn't potentially have an A, it definitely has an A, and it has a view into A. So it definitely has an A, and that view is called a lens. Didn't I just do that? Anyway, hang on, what did I do? Copy and paste. All right, so the technique that I use, so this is in my actual code, right? So given this sort of setup in that I don't want to keep writing left or over and over again, for every time I change a data type. What do I in fact do? I have to first of all write a type class, such as Leftish. So it has these properties here, and then I have to write an instance for that type class, and that is the instance that is equal to the view of the thing that I'm looking at, in this case A. And then I have to write the instance for that. So if we have a look at all the code for it, there's the type class, we have to write an instance, and we also have to write one other instance. And then the constraints depend on the kind of view. So a lens is a view into a data type where it definitely has that thing as one hole inside the data constructor, such as a pair. So a pair definitely has an A, it also has a B. And when we constrain our P and F, we say P is arrow and F is a functor. And then there's many other possible constraints that we can put on there that give us different properties about how we view into that data type. So I guess a more concrete example, we have this data type here. I think we all sort of start here, where we write down the data type, has an age and a name, and instead of writing records or modify functions for the age, we instead write a type class, and the type class is it's a P from the type of the field, in this case int, and then we're abstracted over S. So S is going to be our target type. Right, so we have an instance for int, so that's just the equivalence instance, so we can always view an int as an int. And there's no constraints required on P and F to do that. However, when we want to look at the age of a person, so looking inside a person, there is an age along with some other data, which is the name. So that is a lens, and because it's a lens, P is an arrow and F is a functor. And so we can now write this instance, and then we write our library functions in terms of this function here. So when we see our type of the type signature of our functions, it doesn't say person, it says something that could be viewed as if it had an age. So then we can add constructors to person, we can add fields to the constructor that already exists, and so on, without having to change those functions. Another example, so going back here, this is a record type, so we're looking at it as a lens. At this data type, we've got a sum type, so a shape is either a circle or it's many other possible things. So the goal here is to talk about things that may have a radius. So a shape is a thing that may have a radius. It will have a radius in the instance that it is a circle. And the goal is to make it so that our types do not mention shape. That is to say, all things that may have a radius. So we write the type class, we write the instance, and then in this case, because the radius is potentially existing in shape, it's a prism, so it has the prism constraints. And these dots here stand for sort of, this program will type check, trust me. Or trust the type checker, really. So then we write our library functions in terms of that function, and as we do so, those types will have the constraint as radius and will not say is or is not a shape. So I'm working on this problem at the moment. I play chess. Who plays chess? Awesome people. So there's a website, you may have heard of it, you may not, it's called Leftish. I play on this website, it's an open source thing, it's written in Scala by Tybalt is his name. So here is the world number 12, this is only a couple of weeks ago, GM Wesley So, an American grandmaster. He goes on to Leftish, and when he does, sort of everyone wakes up and watches. Well, in my case, wake up, because he's in America. So what happened is someone is cheating. Someone is using computer assistance. For those of you who do play chess, you will know this, that computers can beat humans at chess. I guess not like the average computer can beat the best human pretty easily these days. And he kind of got upset and he said, "I'm closing my account. Go away, Lee Chess." And he had a little tantrum and ran away. And I sat there and I thought, this is why. This is why that happened. It happened because in order for it, so I mean, I've played on there. I'm certainly not the world number 12, but I do run into people who cheat. I know that they're cheating, or I strongly suspect it, and I write this note. It's like, "Hey, everyone, I think I just got done over by a cheater," and then humans assess it, and there's a limited amount of human resources to assess this string that I just sent them. So I argue to the Lee Chess programmers, and I said, look, a cheat report should be a data type. All right, so I might think that, like, you can imagine, like, I'm kind of an average chess player, and then one day I play like 3 brilliant moves in a row. It could be coincidence, may not be. So we sort of say that was unhuman. But in terms of detecting cheating, it's quite difficult, but there are certain things that appear to even average players like myself as pretty obviously cheating. And then cheaters are getting more and more sophisticated. So there was actually a report yesterday of a guy who is using a chess computer program from about 10 years ago to make sure that it's not quite the strongest one. And he doesn't play every move out of it. And what else does he do? If it's a much stronger player, he deliberately draws the game rather than wins the game. So he's trying to get quite sophisticated. And people are sort of sitting there going, "Is he cheating? If I say he is, and I'm wrong, and I'm in trouble." So there's this huge problem, which is detecting cheating in chess. So I guess my point is we're writing these reports as humans. Humans assess them and decide whether or not there actually was cheating, and even that may be wrong. And I argue that we should produce a closed data type, but there's an obvious problem with this closed data type, which is there's now a new cheat detection method that we figured out today, because this happens a lot. So this whole idea of cheating is moving so fast that adding constructors to data types is happening. So I argue that we should start doing this. It's written in Scala, which makes this a little bit more difficult, or a lot more difficult, but I argue that we should be doing these kinds of techniques. So I'll give you yet another example. This one is kind of in another one of my hobby areas, which is geodetics. So whenever you sort of turn your GPS on and you've tracked where you're moving or your car's moving, it's usually logged in what's called the GPX data format. And if you have a look at the GPX data format, you'll see that a GPX has this, and this has that, and that has that, and so on. And for those of you who are familiar with lenses, at least a little bit, you'll know that in order to get down into that sort of that tree of object types, you sort of compose all these lenses up together, and then you say, do your operation, and it'll walk down the object graph for you. The incidental advantage is, if I need to sort of go from, say, this level of the tree to this one here, I sort of glue the 3 things together and then do the thing that I need to do. If I do that enough times, I need to come up with an identifier name for that thing that I just did, and that's the hardest programming problem that I've ever had, which is coming up with identifier names. So, we do these kinds of things. Glue this one with this one, this one with this one, and so on. But basically, because I can come up with the data type and say every level of that object graph satisfies this type class, then there's only one identifier name that I need to come up with, and that is it has a latitude somewhere within the object graph. All right, so instead of saying a GPX has whatever it does, tracks, which have track segments and so on, just all of those things have latitudes, and then I just say latitude. No more coming up with identifier names. I'm not joking, that's the hardest problem that I have in programming. It really is. So, let me now tell you about some of the penalties, or at least what I perceive to be the penalties. I'm sure there's more. So every time I do this, I have to do boilerplate. So the lens library comes with lots of great libraries to get rid of boilerplate, and I'm deliberately throwing all of those away in order to do this thing that I'm doing. So every time I have a field or a data type constructor, I have to write all of that, which is a lot. A person has an age and now I've got a lot of work to do. Type errors are difficult. So this is a latitude and longitude. So, you know, that kind of sucks. What does that say? Something about we need to get types to write our programs, as we were told this morning. But I mean, I find these type errors difficult to navigate. It would be much nicer if it said, you know, the floating point number's out of range or whatever it might be. And more importantly, this is actually where my work is rather than my hobbies, which is I want to parse a Java class file. However, I want the type signature to not mention Java class files. Okay? So basically, this is the structure of a Java class file pulled out into type classes. I think it's a bad idea for many reasons. I just wanted to see if I could do it, and I could. So there's the parser right down there, and all the type variables constrained all up there.
If you got rid of the P and F and you just said, hey, look, we're only concerned with prisms or something for a particular case, then most of those would collapse away.
The P and F? Which P and F?
When you put the P and F parameters in all of your classes,
oh, yeah.
You have to care about every functor that you happen to use. If you
the P and F way back here, right? Okay.
Yeah, when you have your P and F there.
Those two.
If you just had the S, right, and you're only concerned about as move number is either a lens or a prism.
Yeah, but I hit it.
Let's just say you only.
If I did do that, yep.
Then.
And I knew it was a
all
prism.
Those parameters vanish.
Then
you can always rely on this working for every prism. That for every data type that you're working on, this acts as a prism. So that doing that for like the lens-like combinators with lowercase names and the prism-like combinators, you asked what are you doing wrong?
Yeah.
That would probably be the biggest single change, like the most empowering change you can make to clean up that code.
Right. So tell me if I've got this right. So if I get rid of this P and the F here, what will happen is the type signature will be specific to, say, prism or lens or traversal or whatever it might be.
You won't be able to find it. Yes.
And as long as the thing that I'm doing would not otherwise exploit that, like exploit that generalization, then I'll get a benefit. So I'm aware of that one. And I probably will rewrite that code to do that. This was kind of like, could I actually do it? You know, how long is it going to take? And the answer is like, you know, most of a day.
We actually dumbed down all of the exception prism machinery that we have in control exception lens. To go from this scheme to the simpler scheme. Because nobody was using it because they couldn't deal with all the P's and the F's.
Yeah, well, my question was, could I deal with it? Yeah. And the answer is like, just. Only barely.
Could do it. The guy could do it. A couple of other people on the Lens project could do it.
Yeah, I've learned how to do it.
Nobody else bothered.
Right. I can see why. Yeah, I now know the answer to why. Yeah. So anyway, I do have this type signature, and I'm not proud of it. I mean, I'm confessing here. But yeah, basically the goal was, could I make this not mention Java source files? And the practical goal was, could I write the parser to work against 1.5 and 1.7 versions of the JVM from the same function, right? So that is to say, if I change the format of the class file, do all the referencing functions need to change? And the answer was no. So I kind of prototyped that. And I think I'd still get that advantage if I did the thing that you said.
The other question I had is, did you just try not writing the signature? Putting the disable of the warning for missing type signatures?
Absolutely, that's what I did. Yeah, I did not type that. Yeah. I kind of progressively worked towards that, but there was a lot of copying and pasting going on. So I guess what I'm getting at is don't, I've gone overboard here, don't do that. And Ed agrees. So, and I think in my particular, my real practical goal was to determine if I could parse both 1.5 and 1.7 without changing the referencing functions. I've got to the answer yes. And I believe that if I did the thing that Ed's mentioned, which is to specialize the types a little bit more, which would collapse all of that down a lot, I would still be able to achieve that goal. So I want to be able to just look at my types and say, this definitely works, right? So when, I've got bigger plans than just Java because Java's quite boring. So moving on. So, yeah, I'll just mention that. So, and I would hope to work with future Java versions just as a use case, not because that is an aspiration of mine. Because it's really not. And I have parametricity, right? So I can just look at the types, and I, by virtue of the fact that they don't mention the Java format, I know that they will work against those future things and alternative things. So it is my opinion that the expression problem, and that is I can write functions that reference data types without referencing them in their types and have those functions still work, has been conquered in part with this technique. However, there are penalties, and I ask you, is there an even better way? And you really is just Ed. So, and anyone else, no, seriously, I would like to know, can we do better? And so thanks everyone for listening. I hope some of that made sense, and I'm happy to take questions.